put equation 9 in 10. So you have to substitute equation 9 in 10. So that is 1 plus reflection coefficient parallel is equal to transmission coefficient parallel is there, that is 2 eta 2 cos theta I divided by eta 2, here you can see eta 2 cos theta t plus eta 1 cos theta I. You can interchange them. Now there cos theta t divided by cos theta t divided by cos theta I is there. Now this theta cos theta I cancel, and 2 eta 2 cos theta t comes actually, and gamma parallel is nothing but 2 eta 2, this cancel, cos theta I cos theta t divided by eta 2 cos theta t plus eta 1 cos theta I minus 1 is there. Okay, now gamma parallel is equal to, it goes here now, then 2 eta 2 cos theta t, eta 2 cos theta t, 1 eta 2 cos theta t remains, then minus of eta 1 cos theta I divided by eta 2 cos theta t plus eta 1 cos theta I. So this is the equation number 11. This is the reflection coefficient. I will write here. What is the definition of reflection coefficient? ER0 divided by EA0. This is the definition. So reflection coefficient of parallel polarization. Okay. It is easy to remember. Eta 2 is in medium 2. In medium 2, angle is theta t. So eta 2 cos theta t minus eta 1 cos theta I. Theta I is in medium 1. So same thing is there, but here plus sign is there. For example, dear students, for normal incidence, theta I is equal to 0, theta t is equal to 0. So theta t 0 means cos 0 is 1. And that means then you get eta 2 minus eta 1 divided by eta 2 plus eta 1. So you can remember this equation. I am putting this here. Actually, after derivation, what equation to remember? No, you remember this equation, students. I am putting star here. Even though so many places I kept box, no, you remember this one. And after this, you remember this one also, this equation. Why I told you to remember that? No, from that equation you will be calculating gamma parallel, reflection coefficient for parallel polarization. You substitute that here. From that you can calculate transmission coefficient. Okay. Now equation 9 and equation 11 are called Fresnel equations. So equation 9 and equation 11, 9 and 11 are called Fresnel's equations. So very simple, you see, students. Yeah, you may think it is very complicated discussion, but simply you have to remember two formulas, this formula and that formula. These are for general case. Now only two formulas are to be remembered, this one and 1 plus gamma parallel is equal to transmission coefficient parallel cos theta t by cos theta I. That formula you have to remember, this one you have to remember. And also Snell's first law, n1 sin theta 1 is equal to n2 sin theta 2. That is nothing but n1 sin theta I is equal to n2 sin theta t. So in that theta I is given, you can find theta t. Theta t is given in some cases, you can find theta I, then you can substitute them here. Where eta 1 is equal to root mu 1 by epsilon 1, I wrote there in the diagram. Eta 2 is equal to root mu 2 by epsilon 2. We are talking of lossless mediums. If you want, you can write here where eta 1 is equal to root mu 1 by epsilon 1 and eta 2 is equal to root mu 2 by epsilon 2. Okay. Now, for example, if reflection coefficient is equal to 0, then ER0 by EA0 is equal to 0, then ER0 is equal to 0, there is no reflected wave, then engineers are very happy, then everything is transmitting. That is very happy discussion. For that, what to do? You have to adjust theta I in such a way this numerator term becomes 0, then gamma parallel becomes 0. In that case, there will be no reflected wave. That happens only at particular incident angle. That incident angle at which this numerator term becomes 0 and gamma parallel becomes 0, that incident angle is named as a Brewster angle. Okay. So, let us write that if gamma parallel is equal to 0, then ER0 is equal to 0, because this is ER0 by EA0 is equal to 0. So, in this case, there is no reflected wave. So, in this case, there is no reflected wave. In this case, there is no reflected wave. The incident angle at which gamma parallel is equal to 0. Gamma parallel means reflection coefficient of parallel polarization. If you want, you can write there. Is 0 is called as the Brewster angle. Called as the Brewster angle, that is theta B, and this is for parallel polarization, so theta B parallel is written. Okay. Now, here theta B parallel means Brewster angle for parallel polarization, and here gamma parallel is reflection coefficient for parallel polarization. Similarly, transmission coefficient for parallel polarization. Okay, right. Now, put gamma parallel is equal to 0 and theta I is equal to theta B parallel in equation 11. In equation 11. Then what you get? So, eta 2 cos theta t minus eta 1 cos theta B parallel, okay, is equal to 0. Then you get eta 2 cos theta t is equal to eta 1 cos theta B parallel. Now you take squares, na students. What will happen? Eta 2 square cos square theta t is equal to eta 1 square cos square theta B parallel. Okay. Now let us write in terms of 1 minus sine square. So eta 2 square, this is 1 minus sine square theta t is equal to eta 1 square 1 minus sine square theta B parallel, because we are interested in applying the Snell's law here, that is why. So let us say the 11, equation number 12. So what is Snell's law? Snell's law is N1, not eta 1 student, this is N1 sin theta I is equal to N2 sin theta t. Now N1 is root mu r1 and epsilon r1. Already I have written this somewhere. If you have any doubt, you see there. So then this is sin theta b parallel is equal to, this is root mu r2 epsilon r2, what do you say, sin theta t. Actually, if you see carefully, here mu naught epsilon naught can be multiplied here, so that is simply mu 1 epsilon 1 sin theta b parallel is equal to root mu 2 epsilon 2 sin theta t you can write. So from this sin theta t, because we want the equation for theta b parallel, but here theta t is there. So from this you can write sin theta t in terms of sin theta b parallel. So what you get is root of mu 1 epsilon 1 divided by mu 2 epsilon 2 and then sin theta b parallel. Let us say this equation number 13. Now you substitute this equation 13 in this one, put equation 13 in equation number 12, then you get that side. So eta 2 square 1 minus of sin theta t is this one whole square you have to do. So mu 1 epsilon 1 mu 2 epsilon 2 sin square theta b parallel is equal to, that is eta 1 square 1 minus sin square theta b parallel. Okay. So if you simplify this equation, actually directly I am writing, students, so let us not waste our time. Now both sides sin square theta b parallel sin square theta b parallel are there. Now anyway eta 2 is nothing but root mu 2 by epsilon 2. Eta 1 is nothing but root mu 1. This is root mu 2 by epsilon 2 whole square, that means mu 2 by epsilon 2. This is eta 1 square means mu 1 by epsilon 1. So from this you can find sin square theta b. Here you get sin square theta b parallel, Bros triangle for parallel polarization, that is 1 minus of mu 2 epsilon 1 divided by mu 1 epsilon 2 divided by 1 minus of epsilon 1 divided by epsilon 2 whole square. Anyway, this equation you are not going to remember, but one more equation is there that is easy to remember. Actually, here we are taking medium 1 has mu 1 and medium 2 has mu 2, but in examination always we get the questions that medium 1 also dielectric, medium 2 also dielectric. If medium 1 is dielectric, medium 2 dielectric, then mu r1 and mu r2 is equal to 1. If these two are 1, then automatically this is simplified. That formula you have to remember. But if, I am not putting star mark to this. It depends on your patience whether to remember or not. But another formula we will get, I will write that one. Anyway, this is equation number 14. Now, this is the general case which I am writing. If medium 1 and medium 2 are dielectric mediums having mu 1 is equal to mu 2 is equal to mu naught and lossless mediums. Of course, students, because this discussion we are doing with by taking lossless mediums only. Then equation 14 is sin square theta b parallel is equal to, I told you this cancel, so epsilon 1 epsilon 2 divided by 1 minus epsilon 1 by epsilon 2 whole square, that is equal to this one you get this is a square minus b square na, 1 plus epsilon 1 by epsilon 2. So sine square theta b parallel is equal to this cancel, epsilon 2 by epsilon 1 plus epsilon 2 under root, that becomes sine. So this formula also you may not remember. That is your wish to put in the box or not. In the tan form we will remember, student. Tan form, no? So now this is opposite. This is hypotenuse. Okay. In the triangle, this is theta b parallel. This one is opposite, and this one is what you say hypotenuse, epsilon 1 plus epsilon 2. And now adjacent is equal to what? Hypotenuse square minus this square, that means epsilon 1 plus epsilon 2 minus epsilon 2, you get epsilon 1. Again you have to take root, so you get this one root epsilon r1. Okay, here adjacent is equal to root epsilon 1 you get. Okay, now from this tan theta b parallel is equal to opposite divided by adjacent. So you are going to remember this tan theta b Bros triangle for parallel polarization, root of epsilon 2 divided by epsilon 1, that is nothing but epsilon r2 divided by epsilon r1, because epsilon naught cancel, you get this one. So this formula only they give in examination, because always we take dielectric mediums 16, but it depends on your interest whether to remember this or not. If you remember this, it's okay. But in rarely till now they have not asked medium 1 having some mu r1, medium 2 having different mu r2. They did not ask. But if they ask, they have to use that equation for Bros triangle. So otherwise, if medium 1 and medium 2 are lossless and they have mu r1 is equal to mu r2 is equal to 1, this is the Bros triangle formula which you have to use. So dear students, here simplified formula, let us simplify that one. For non-magnetic, that means mu1 is equal to mu2 is equal to mu naught. Dielectric, of course, cellulite lossless. Okay, dielectric means lossless only. Dielectric mediums, equation 11, that is transmission coefficient, and equation 9 becomes, they are further simplified, students. Gamma parallel is equal to ER0 divided by EI0 is equal to, it comes in very simple form, tan of theta t minus theta I divided by tan of theta t plus theta I, they come. So this is the case you have to remember. So this is equation number 17, right? Anyway, I will write the transmission coefficient. If you substitute this here, then you get the transmission coefficient. So transmission coefficient you get that 2 cos theta I sin theta t divided by sin of theta t plus theta I and cos of theta t minus theta I, and I don't suggest you to remember this one, no need. So now I am finalizing the discussion. What is the discussion? I told you to remember this equation if mu1 and mu2 are not equal, then this equation you have to use mu1 and mu2 have different values, then this is general equation. If you remember this equation, you substitute that here, you get automatically transmission coefficient for the parallel polarization. That means 2 equations over. After that, if medium 1 and medium 2 have same permeabilities, this one, then reflection coefficient is very simple. Tan of theta t minus theta I divided by tan theta t plus theta I, and you have to remember this equation. Now if you substitute this here, then automatically for this case you get transmission coefficient. That means how many equations you have remembered? One general equation and this one. This is simplified equation for this case, and already you have remembered this one. So that means total till now 3 formulas you have remembered, and this is the 4th formula. Whenever this is the case, mu1 is equal to mu2, then what do you say? Broch triangle is this one. Total how many formulas you have remembered, dear students? Total 4 formulas. One is general reflection coefficient, and this one 2 over, and reflection coefficient for the simplified case. This is what they ask in examination, and this is 3rd formula, and that is the formula you have to remember. It is simple, students, right? So dear students, let us talk of perpendicular polarization. In this perpendicular polarization, incident wave electric field is out of the board here. That is, electric field is perpendicular to the plane of incidence actually. That is why it is called perpendicular polarization. Or otherwise, this is the, what do you say, this one is the reflecting surface. This one, no? This one is the reflecting surface, this one. So this electric field is parallel to the reflecting surface. Here S stands surface, so S polarization, and it is also horizontal to the what do you say, boundary surface. That is why it is called horizontal polarization. So these names came from the electric field horizontal to the boundary surface. So this is the boundary surface, or otherwise reflecting surface. Incident wave hits like this and reflected like this. Now this horizontal polarization means incident electric field is horizontal to this reflecting surface. So here S means surface, here reflecting surface. And actually these names are rarely used. This is the name used always, that is perpendicular polarization. What is the meaning of perpendicular polarization? Here electric field is out of the board. This is magnetic field. Dot means out of the board. Beside that EA is written. Electric field is out of the board. Here also electric field is out of the board. Here also electric field is the out of the board. Now here I am writing here, dear friends, Z is equal to 0. That means XY plane is boundary surface. Boundary surface. Next, XZ. XZ plane, or otherwise on XZ plane, incident. Incident means this one. Wave and AN cap. This is nothing but AN cap only, that is AZ cap. Same as previous case, student. That is why no need to explain much. So on XZ plane, incident wave and AN cap are present. So XZ plane, or otherwise board plane, XZ plane is called plane of incidence. In this case, in this case, here, this one, electric field is perpendicular to the plane of incidence, plane of incident. So it is called as perpendicular. Symbol is this one, perpendicular polarization. Once again, I told you, if you take this is the wave propagation direction, then this is electric field direction, this is magnetic field direction. You can check here. This is wave propagation direction. Here it is like this. This is wave propagation direction, this one. This is magnetic field direction. You can see here. This forefinger is out of the board, that is electric field. This thumb is the magnetic field. This is wave propagation direction. You can see here also like this. This is wave propagation direction. Out of the board is the electric field direction. This thumb is magnetic field direction. And this is also same way. This is the wave propagation direction. Thumb is magnetic field direction. Out of the board is electric field direction. The analysis is exactly same as previous case. Exactly same. And if you do the same analysis, you get equation of transmission coefficient for perpendicular polarization, this formula. And this formula relation between reflection coefficient and transmission coefficient is same as the normal incidence case, that is 1 plus reflection coefficient is equal to transmission coefficient. Now you have to remember this formula. I am not putting star mark here, no need to remember that. This formula you remember for general case, eta 2, here just angles are interchanged. Earlier theta t was there here, now theta I comes. Earlier here theta I was there, here theta t comes. Then whatever is there in numerator, same thing, but plus sign will be there. Just cos compared to parallel polarization, in perpendicular polarization, cos terms are interchanged. I mean here cos theta t was there, now it came cos theta I. Here cos theta I was there, it came cos theta t. That much is the difference. So you remember this formula for general case. Then if you remember this, you find what do you say, gamma for perpendicular polarization. If you substitute this here, you get this one. So this equation and this equation are called Fresnel equations for perpendicular polarization. Once again, where eta 1 is equal to root mu 1 by epsilon 1 and eta 2 is equal to root mu 2 by epsilon 2. And this equation you remember. At theta I is equal to theta b, Brewster angle for perpendicular polarization, that is the meaning angle, you make this 0 similar to previous one, then ER0 is 0, then we get a sine square theta b perpendicular this equation. I am not putting this in the box, that is your wish to remember, but you will not get that in examination. Here theta b perpendicular is Brewster angle for perpendicular polarization. Okay. Now, what is the actual case? If both mediums are non-magnetic, that means mu 1 is equal to mu 2 is equal to mu naught, non-magnetic and lossless dielectric mediums, then you see this one. If mu 1 is equal to mu 2, this is 1 minus 1 is what do you say, 0. Denominator 0 means infinity. Then theta b perpendicular becomes infinity, means sine value can never become infinity. That means it is meaningless discussion. So it is meaningless discussion means that does not exist. That means this type of case is not possible in that. That means you Bros triangle does not exist here. Whatever might be the incident angle, definitely this cannot become zero. That means there exists a reflected wave in this. So that is why you have to write here that for perpendicular polarization, Bros triangle does not exist. That means you incident angle may be any angle. Definitely there exists a reflected wave because gamma perpendicular cannot become zero. Then sine square theta be perpendicular is infinity, so that means not valid, this one not valid. So that is why I am writing here for non-magnetic, that means mu1 is equal to mu2 is equal to mu naught. For non-magnetic dielectric mediums, Brewster angle does not exist for perpendicular polarization. So this is the conclusion. This you have to remember. Now similarly, for lossless, that means sigma 1, sigma 2, 0, non-magnetic dielectric mediums, if you simplify this equation and then you get this one. Earlier in case of parallel polarization, this was tan theta t minus theta I, tan theta t plus theta I, and in case of perpendicular polarization, in place of tan, you get sine. So this is very simple formula, a very important formula you have to remember. And in examinations, always you get this case only. Both mediums, always you get non-magnetic materials, that is mu1 is equal to mu2 is equal to mu naught. Always you get this one. This formula you have to remember. And you substitute this one here, you get transmission coefficient. So this is very simple discussion, but in examination, always they give this. So this formula you have to remember. For previous case, tan theta I, theta t minus theta I, here in place of tan you get sine, student. So now we can solve some questions based on this one. So dear students, now let us write one note here. This is a standard discussion. So this is note. First point. For example, this one is medium 1, top side medium 1, and bottom side it is medium 2. So I am writing here also it is medium 2, it is medium 1. I will write here it is medium 1. Okay, that means this is the boundary surface. Now if incident wave is coming like this and reflected wave is going like this, so this is a reflected wave and this one is a incident wave, and of course this one is a transmitted wave. Transmitted wave. Now what is the question? It is given that actually it is note 1. Okay, so this is medium 1. So this incident wave, it is given, it is circular polarization. Which polarization? Circular polarization. It is standard question. So here incident wave is given as a circular polarization. Now the question is, what is the polarization of this reflected wave? So dash polarization. Okay. And similarly, what is the polarization of this transmitted wave? So we have to answer this one. what is the actually question is, once again I am saying, uh, incident wave is a circular polarization. Then what is the polarization of reflected wave? What is the polarization of the transmitted wave? Anyway, for your convenience, this is and this should be equal, na? It doesn't matter. So this is reflected wave. Okay, what is the polarization of this? You need dash polarization. This is transmitted wave. What is the polarization of transmitted wave? Once again, I am saying, students, the question is, incident wave polarization is circular polarization. Then what is the polarization of reflected wave? What is the polarization of transmitted wave? That is the question. So this is actually a n cap, and this is theta I, this is theta r, and this one is theta t. Okay, this is medium 1 top side, this is medium 2 bottom side. This is the boundary surface separating medium 1 top side, and this is medium 1, and this one is medium 2 bottom side. Now what I do to solve this one, circular polarization, we have studied in circular polarization, whatever we have studied, from that only we will take example. For circular polarization, electric field x component and electric field y component both have same magnitudes. So I will take Ex is equal to Ey. Now this is incident wave. I will take this as a, because both are one is, if you take this as a parallel component, this will be perpendicular component. So for circular polarization, electric field x component is equal to electric field y component. I am selecting this is for incident wave. This is also for incident wave. I am selecting for your convenience, I am selecting this as a parallel component. Automatically this one will be perpendicular component. So perpendicular component, for your convenience I am taking. Now can you tell me what is the reflected what is the reflection coefficient of parallel polarization? That is equal to reflected divided by incident. Anyway, reflection coefficient, student, reflection coefficient is reflected by incident, and reflection coefficient is equal to reflected by incident. That implies reflected electric field is equal to reflection coefficient into incident electric field. Reflection coefficient is equal to reflected electric field is equal to reflection coefficient multiplied with incident. Now if this is the reflection coefficient of parallel polarization, then you have to take parallel here. So if this is the reflection coefficient of perpendicular polarization, then this is the reflection coefficient of perpendicular polarization. Now already you know, for example, the formula of reflection coefficient of parallel polarization is tan theta t minus theta I divided by tan theta t plus theta I. And for perpendicular polarization, reflection coefficient is sine of theta t minus theta I divided by sine theta t plus theta I. That means formulas themselves are different. If formulas are different, then these values also you get different. So reflection coefficient of parallel polarization is not equal to reflection coefficient of perpendicular polarization, because formulas are different. These two are not equal. Now come to the conclusion. Here for circular polarization, this EI parallel and EI perpendicular both are equal, but this one and this one are not equal. Because they are unequal implies ER parallel is not equal to ER perpendicular, then this becomes elliptical. Unequal, na? They are unequal, elliptical. So dear students, this is elliptical polarization. This is also elliptical polarization. Without doing mathematics, I will tell you in one statement. Circular polarization, both components are equal. Then the reflection coefficients for parallel polarization and perpendicular polarization are not same. So unequal magnitudes are reflected, and from equal magnitudes, unequal magnitudes are reflected, unequal magnitudes are transmitted. So unequal magnitude means elliptical polarization. So this is also elliptical polarization, and this is also elliptical polarization. This is standard question. Now, what is the standard question? If incident wave is circularly polarized at any incident angle, it is not Brost angle, just like that any angle, then reflected wave is elliptical polarized and transmitted wave is elliptical polarized. That is the discussion. Now note 2 I am taking. In place of theta I will take theta B, Brost triangle. So now what will happen? This an cap and this is the incident and this is the reflected, this is the transmitted. So this is medium 1 and this is medium 2. I am writing both sides. This is all medium 2, this is all medium 1, and this is the incident wave and this is the transmitted wave, and this is the reflected, na student, not transmitted. This is the reflected wave and this one is a transmitted wave. Now what is the polarization of this one dash? What is the polarization? Similarly, what is the polarization of this one? Now this is an cap, this is theta t, this is theta r. Now it is given that this is theta b. Incident angle is equal to theta b. You may ask question, which theta b, for parallel polarization theta b or perpendicular polarization theta b? Already we have studied for perpendicular polarization Brost triangle doesn't exist. Automatically this Brost triangle is for parallel polarization only. So now of course this is also theta r is theta r also equal to Brost triangle only now, definitely, because theta b, this is theta I and theta r both are equal, so that is nothing but theta b only. In this case, if it is circular polarization or otherwise it may be elliptical polarization, if incident wave is circular polarization or otherwise it is elliptical polarization, it is given student, it is given. कुछ बच्चे लोग बोलता है कैसे मालूम है ये सर्कुलर पोलराइजेशन करके, वो दिया हुआ है, वही है क्वेश्चन. सो it is given that incident wave is circular polarization or otherwise elliptical polarization, then incident wave is at Brost triangle, then what is this reflected polarization or otherwise transmitted wave polarization? Okay, this is once again I am telling, it is given, दिया हुआ है, it is given that incident wave polarization is circular polarization or otherwise elliptical polarization, then it is hitting the boundary at Brost triangle, then what is the polarization of this? कुछ बच्चे लोग फिर पूछता है ये दोनों इक्वल नहीं है करके, ये दोनों इक्वल है और भी नहीं है और थोड़ा सा ऊपर, थोड़ा सा ठीक है, ये वाला भी theta r is equal to theta b reflected hai. Okay, so dear students, now how to analyze this one? Very simple. Let us say for this incident Ex is equal to Ey. One is for incident wave electric field, one is parallel component you take, other one will be perpendicular component. Now you students know that here at the Brost triangle, gamma parallel becomes 0. For parallel polarization becomes 0. That means electric field, reflected electric field for parallel polarization is 0, but gamma perpendicular not 0, and that implies reflected electric field perpendicular component only present. I told you na, case 1, case 2 in polarizations. Case 1 only x component is there, only y component is there, then that is called linear polarization. So here if you take this component x component here, that will not be there. Only one component will be there here. If only one component is there, that is linear polarization, dear students. So this is linear polarization. Actually, for two components are there, out of them one component is reflected, that is why it is linear. Then definitely unequal magnitudes come here, so it is elliptical polarization. It is elliptical polarization. Why only one component is there here? Because at Broch triangle, reflection coefficient for parallel polarization is 0. That is why a reflected electric field for parallel polarization is 0. So only perpendicular component will be there. If single component is there, that is called linear polarization. This is standard question. So anywhere if they give circular polarization or otherwise elliptical polarization, and here if they mention linear polarization, automatically that incident angle should be Broch triangle. Then note 3 I am writing. So let us take medium 1 is air medium. So that eta 1 is equal to 120 pi. And medium 2 is dielectric medium. Then for dielectric, eta 2 is equal to 120 pi divided by root epsilon r2. That means mu r2 is equal to 1 for this. Okay. Now this is medium 1, this is medium 2 bottom side. This is the boundary surface. This is the incident wave. Now it is given RCP, right circular polarization for this. It is given incident wave has right circular polarization. Now what is the polarization of dash polarization? This is reflected wave. This is reflected wave. What is the polarization of this? What is the polarization of this? It is asked. Similarly, for transmitted wave, what is the polarization? Dash polarization for the transmitted wave. Now, reflection coefficient. Now I am answering here. I am writing the answer here. Explanation. Here if you see, eta 1 is 120 pi and epsilon r2 is greater than 1. So denominator greater than 1, overall this is less than 120 pi. So ultimately eta 2 is less than eta 1. So eta 1 is bigger because 120 pi divided by greater than 1. So eta 1 is bigger. So reflection coefficient is equal to eta 2 minus eta 1, eta 2 plus eta 1. So that is always eta 2 is eta 1 is bigger. So that is actually negative, it comes negative value it is because eta 1 is bigger. So what is this? ER divided by EI is negative. That implies ER is equal to negative into EI. That means negative into EI, incident is given RCP. So negative of RCP is opposite of RCP is LCP, student. So this is answer is left circular polarization. And here transmission coefficient is equal to 2 eta 2 divided by eta 1 plus eta 2, that is positive, and ultimately ET by EI is equal to positive. That means ET is equal to positive of EI, that is positive of incident is given RCP. So that means you get once again positive into RCP is RCP only, right circular polarization. This you get RCP. So there are some questions in the workbook based on them. Now let us solve them. Okay, that question number 40 in GATE workbook, that question number is 34. Okay, question number is 34. So diagram is given like this. It is incident wave is RCP actually. Incident wave is like this arrow mark means incident. It is given RCP. circular polarization, and it is given linear polarization. Linear polarization. And epsilon R1 is 1, and epsilon R2 value you have to find. This is the transmitted, and he has given this angle also 60 degrees, this angle also 60 degrees. Now you have to find this one. It is very simple. Incident is circular polarization and reflected is linear polarization. This is the case. Incident is circular polarization, then reflected is linear polarization. Then definitely this angle should be Bros triangle only. So that means this angle should be Bros triangle. So that means so given theta b is equal to 60 degrees. It is not given, we are understanding that one. So it is circular polarization, then it is linear. That means the incident angle should be Bros triangle. So you have to find this one. So theta b is 60. Now you know that tan theta b is equal to root epsilon 2 by epsilon 1, root epsilon 2 by epsilon 1. That implies tan 60 is equal to root of epsilon r2. This is 1 is given. So from this tan 60 is root 3 root epsilon r2. That means epsilon r2 is equal to 3. So the option is D. In option D it is there. So that is the answer, option D. Now question 41, for gate it is actually question 35. Okay. For an elliptically polarized wave incident on the interface of a dielectric at Bros triangle, the reflected wave will be, once again he is saying same question, incident wave is at Bros triangle, then reflected wave is linear polarization. So answer is B. What is that actually? If incident wave is at Bros triangle, then reflected wave will be, then reflected wave will be, so incident it is at Bros triangle, then reflected wave is will be, option B is correct, linear polarized. So that is the answer. Then next question is based on this one. So that is question number 42 in regular workbook. In GATE workbook actually question number 36. Okay. Right circularly polarized wave is normally incident from air onto the polyester. So like this he has given right circularly polarized air to polyester. So polyester, and this has epsilon r value 2.7 he has given. That means epsilon r2 is greater than 1. So it is air medium. Then the reflected wave will be dash polarization. So it is RCP given. Then what is answer? LCP, left circular polarization. This one only, this discussion. That is note 3. So this is the answer. So option is left circularly polarization. Option is B. Answer is B. So in B it is given LCP. So this is the answer. Right? So dear students, you see this question. A monochromatic plane wave of wavelength is given, is propagating in the direction as shown in figure below. So this is medium 1, because in medium 1 incident wave and reflected wave are present. Bottom side is medium 2, their transmitted wave is present, it is given. For this epsilon r2 is 4.5, for this epsilon r1 is 1. Now EI is incident and ER is reflected and ET is transmitted. Electric field vectors associated with the wave respectively it is given. Now actually it is GATE question, 4 marks question, 2 marks, 2 marks. And what is theta I value and EI bar equation, and here what is ER bar equation, it is asked. Now let us see the polarization. Here you can see that this one always both is plane of incidence. This electric field is parallel to the plane of incidence, so this is parallel polarization. So this is parallel polarization. Here EI is parallel to plane of incidence, that is board surface. So it is parallel polarization. That means you have to use reflection coefficient formulas for parallel polarization. You have to use parallel polarization. Now theta t is given, student, 19.2 degrees actually. From that you can find theta I. So Snell's law is root epsilon r1 sin theta I is equal to root epsilon r2 sin theta t. So from this, what do you say? Root epsilon r1 is actually 1 is given here, no? 1 is given. Sin theta I is required. That means root epsilon r2 is 4.5. So sin theta t is 19.2 degrees. From this you will get theta I is equal to 45 degrees. So theta I, we get 45 degrees, students. Now lambda is given as 600 micrometer. Now from this beta 1 is equal to 2 pi by lambda 1, and that is nothing but 2 pi divided by 600 into 10 to the power minus 6. So this value you get beta 1 is equal to pi by 3. So pi by 3 10 to the power 4 you get beta 1, right? Now you need EI, electric field equation, in phasor domain, EIS bar. Already you know how to write them. So electric field direction in the exponential wave direction. So I am writing here like this. I will take the electric field like this. Okay. In the options, if you see, that fellow has taken EA0 as E0. Anyway, doesn't matter. This electric field magnitude, I will take EA0. Now, this has tangential and normal components. So you can write like this. This is normal, na? Okay, this makes 90 degrees. You can do like this also, or otherwise like this also, doesn't matter. You can write anyway. So I will take here like this. That is next. This is horizontal. It should be 90 degrees to this one because this is parallel, 90 degrees. Now I will draw a horizontal line here like this. Okay. Then like this. So this electric field direction is like this. So this is EI0 like this. Now this one. So angle between here, angle between this one and vertical is theta I. Angle between this is vertical line, and this line is theta I. See, dear students, this is vertical, and this one. So that means here you get theta I. So ultimately, this is the vertical one, and this one is horizontal. Can you tell me what is this angle, dear students? This is incident wave, and this one 90 minus theta I. Actually 45 you got theta I. So this is 90 minus theta I. So that you got that is equal to 90 minus 45. So once again this is also 45 degrees only, this one. So that means angle between horizontal and this one is 45. So this is horizontal and this wave propagation direction. This is 45 now, and here also 45 you will get. Okay. So this is EI, and this value becomes EI0 into opposite is sine 45. This is opposite, na? Sine 45. And I am writing here no place is there, so I will remove this. This one is nothing but EI0 into cos 45. Of course, sine 45, cos 45 both are equal. By root 2, by root 2 you get. So here place is not there for beta I, student. Anyway, I will remove this one. You might have written that. So this is beta 1, right? This is wave propagation direction. This is beta 1, and I am writing this has tangential and normal components. Okay. So can you tell me what is the angle between this one and vertical? 45 degrees. So that means this is also 45 degrees. Okay. Or otherwise this one, what is the angle between this line and the horizontal? 45. This is also 45, and ultimately this one is 90 degrees. I have done perpendicular. This is 45. Here place problem is there. Anyway, now you can write if this is beta 1, this is 45 degrees. Okay, student. I will draw that diagram here, students, so that you will not be confused. I will draw this diagram here. So this is parallel to this, that is beta 1. Okay, I am drawing here. Now this beta 1 has like this, beta 1 like this I will draw. Okay. What is the angle between wave propagation direction, that means this one, and the horizontal line, that is 45. So this is 45 degrees. So this becomes beta 1 touching cos 45, and this is beta 1 sin 45. So dear students, here place is not there, so beta 1 is taken here, that is parallel to this one, and this has a horizontal and vertical. This arrow mark should be given in this arrow mark direction, like this and like this. So the angle between wave propagation and this is wave propagation and the horizontal line is 45. So the angle between wave propagation and the horizontal line is 45. So this is beta 1. Beta 1 cos 45, this one, beta 1 sin 45. So this is in which direction you can see here? That is given x direction. This is in which direction you can see here? Z direction. That is given in the question. If not given in the question, you can't do anything. So similarly, for reflected wave, here I will take first beta. This is also beta 1. You know why? This is in medium 1. In medium 1, that is beta 1. So this is like this. And what is the theta r and theta I both are equal. So that is also 45 degrees. So this one, if this is 45, this one also 45. This one also 45 degrees. Okay. What is the angle between this line and horizontal? 45. So that means this is also 45 degrees. So this is beta 1 sin 45, and this is beta 1 cos 45. This gives direction. If you see electric field here, This is ER0 value that has a, this is perpendicular. This has a horizontal component like this. I will write this is ER0 like this and like this. You have to follow these arrow marks. For ER0, electric field arrow mark is this one. Then the horizontal component and vertical component, the arrow mark should be followed. The angle between, of course, this you get 45 degrees, student, no need to discuss actually. So you can see, if you want, I will explain. This is a, this one is a wave. This line is wave. Angle between reflected wave and horizontal line is 45. Here, angle between this wave and horizontal line is 45. So this is 45 and this is also 45 because the total angle is 90. Now this one is ER0 into opposite is sine 45, and this one is ER0 into cos 45. This is this one. This is beta 1. Now EIS is equal to incident 1. Na? Here you can see. Directly you can write. Like this means that is x-axis. So EI0 into cos 45. So EI0 into cos 45 is root 2. Then this is AX cap. This is AX cap. Then can you tell me what is this? This direction is z direction it is given. It is minus z direction. So EI0 by root 2. EI0 by root 2 minus z direction, that is. So that is the electric field direction. Now from the beta direction, e power minus j you write, then beta 1 is this one. So can you tell me what is this direction? Here x direction. So beta 1 cos 45 is root 2. So this one beta 1 is this one. So pi by 3 root 2 into 10 to the power 4 x you get. Down direction, that is z direction, z you should write. Beta 1 sin 45 is beta 1 by root 2. Beta 1 is this one plus pi by 3 root 2 into 10 to the power 4 z you get. So this is the equation of EIS. You can see this he has given EI0 by root 2 common, AX minus AZ, then e power minus j. So pi by 3 root 2 10 power 4 common, then x plus z comes. Then this option, okay, this is the answer. This is an option C. This is an option C. Option C is correct actually. Okay. Yes, that is an option C. Okay. Now, how to calculate this ER bar? How to calculate ER bar? For that, you have to calculate reflection coefficient. So reflection coefficient of parallel polarization is equal to ER bar divided by EI bar. So that is nothing but tan theta t minus theta I divided by tan theta t plus theta I, that is equal to tan theta t is 19.2 degrees minus theta I is 45 divided by tan 19.2 plus 45 degrees, and this value it becomes minus 0.233, this value, and ultimately ER0 is equal to minus 0.233 into EI0. Okay. Now let us write ERS in phasor domain. ERS is equal to, here you can see this is ER0. ER0 into cos 45. That means ER0 by root 2 like this direction, that is minus AX. So ER0 by root 2 into minus AX. Next, this is minus AX. Like this, ER0 by root 2 into minus AZ. So plus ER0 by root 2 minus AZ. Exponential minus J, you can see here the betas you can see. This is like this, beta 1 by root 2, this is AX. So beta 1 is what, dear students? Here we found na. Okay, first I will write beta 1 by root 2 into X. Next one, this one, beta 1 sin 45, beta 1 by root 2 opposite of Z. So that is beta 1 by root 2 minus Z, that is. Okay. So ER0 is that means ER0 divided by root 2, that is minus AX minus AZ, then e power minus j. Here beta 1 is here it is there, pi by 3, here root 2 also is there, 10 to the power 4 common, in both of them same is there, so that is x minus z. And here in answers, if you see, he has written ER0 in terms of EI0. You can substitute this one. That means ER0 is equal to minus 0.233 EI0. Okay. Divided by root 2 minus of AX minus AZ. So this is e power minus j pi by 3 root 2 10 to the power 4 x minus z, this one. In the options, yeah, it is given like this only without multiplication. So minus into this one becomes a plus student. So this is plus, minus is removed. So this is an option. It seems option A, that is. Okay. Yes, that is in option A. So option A. So actually here I have discussed this splitting of the electric field and splitting. Splitting मतलब हॉरिजॉन्टल वर्टिकल निकलना है, वो बोल दिया मैं आपको. वो थोड़ा सा वही चीज को 3-4 बार प्रैक्टिस करो आप लोग घर में, वो आपको आसान से हो जाएगा. ओके. So dear students, now let us see this note. You remember this one. Actually, one napper means E. This E that is 2.71. Actually, this E comes in electric fields and magnetic fields. You have seen in electric field EA0 into E power minus alpha z. E power, E was there. So E is 2.71. So whenever any term comes in electric fields, then decibels, if you want 20 log, you have to take. So 20 log 10 base E, that becomes 8.686 decibels. So 1 napper in decibels is 8.686 dB. This also remember, sometimes in problem calculations you may need this conversion. Okay. Now in regular workbook question number 39, in GATE workbook question number 33, you see this one. A plane wave propagating in air with electric field is incident on a perfectly conducting slab positioned at x is less than or equal to 0. X less than or equal to 0 means x greater than or equal to 0, air medium is there. That means x equal to 0 is the boundary surface. For us, that boundary surface is important actually. Now if I draw the diagram here, so you can see here, this one is a conductor. Okay, conductor, and here boundary surface is x is equal to 0. So this one side air medium is there. Now what is important here, boundary surface name is important. For x less than 0, this side x less than 0 you take, automatically this is x greater than 0, this is x equal to 0, that is the boundary surface. Now you students should understand that, for example, here I am taking this is an cap, an cap. Now, if incident electric field, this is, we will call it as EI. If incident electric field is hitting like this, then reflected electric field ER comes back like this. Now you should understand here, you see this one. If EM wave hits x equal to 0 boundary, then here if you see, it is traveling in minus x direction and plus y direction. That means wave is on xy plane. Of course, wave is traveling in minus x direction and plus y direction. Now, whenever this wave hits x equal to 0 boundary, then in x direction reversal happens. That means this is traveling in which direction? Minus x direction, incident wave. So reflected wave travels in plus x direction. I am writing one statement. So incident wave travels in minus x direction and reflected wave hits x equal to 0 boundary and travels in plus x direction. Actually, near the conductor reflection coefficient is equal to -1, you know that. So near the conductor surface reflection coefficient is equal to -1. Now this exponential term becomes here this ER bar equation something into e power j omega t, here minus 3x minus 4y. There is no change in y direction. So now reflected wave travels in x plus x direction and plus y direction. So that means reflected wave travels in xy plane actually, right? Question is also same thing. Now I have written this term for reflected wave. Now I have to write this one. Now I am writing here, for x equal to 0 boundary, x component is a normal component. Okay, x component is normal component. Y comma z components are tangential components. That means tangential component of incident electric field vector is y comma z components are tangential components. So 6ay and plus 5az. Now at the conductor surface, total electric field tangential component is 0. We have derived that. At the conductor surface, total electric field tangential component is 0. That means total electric field tangential component means tangential component of incident wave and tangential component of reflected wave gives total tangential component. So total tangential component at boundary surface. Now this is equal to electric field tangential component. This is at boundary surface. Otherwise, this is nothing but total tangential component at boundary. Now this is 0. 0 is equal to ETR plus ETI. That implies tangential component of reflected electric field is opposite of this one, minus 6 AY and minus 5 AZ. Okay. Now here it is like this. Normal component of reflected electric field. This is normal component of reflected electric field is simply ENR, that is magnitude, and some you say actually normal component, dear students. Here normal component is X component, so we don't know what is that value. So normal component is X component actually. So we have to find that one. So normal component, this is what is this? We do not know the value of this. That is normal component of reflected electric field. Now reflected electric field is equal to, that is the tangential component of reflected field plus normal component of reflected field. That implies ER bar is equal to, can you tell me ER bar from this? So ENR, this is reflected normal component magnitude AX plus then ETR, because the X component I am writing first. Then this tangential vector is minus 6 AY and minus 5 AZ. Okay. Now from this, what is unit vector in power flow direction for reflected wave? Then I told you how to write that. Here minus is there means you have to write plus 3 in place of X, AX cap. Here minus is there means you have to write plus. In place of 4 as it is, in place of Y, AY you write. Then this is root of 3 square plus 4 square. This gives power flow direction of reflected wave. So you know that for uniform plane wave, electric field unit vector for reflected wave dot power flow unit vector for reflected wave dot product is 0. Now that implies electric field unit vector is E NR AX minus 6 AY minus 5 AZ divided by root of ENR square plus 6 square plus 5 square. Anyway, no need to write this one, because in dot products equal to 0, this goes that side, it becomes 0 actually. Now APR is 3AX plus 4AY divided by root of 3 square 4 square is equal to 0. So ultimately this is nothing but you can see here, students, this goes this side, becomes 0. ENR into 3 AX dot X is 1. Next minus 6 into 4, then Z component is 0. So ultimately from this ENR is equal to it goes this side 2 times you get 8. So ultimately that electric field component I will write here. Okay. So ENR, how much you got? 8 you got. So now this is the electric field vector 8AX. Here you have to write 8AX then minus 6AY minus 6AY minus 5AZ. Now this is the answer. It is in option C actually. Option C, right? So that is 8ax minus 6ay minus 5az e power j omega t minus 3x minus 4y. That is the answer. Option is C. So what you have done? Just I am giving the procedure in one line. This EM wave hits the conductor surface, then it is reflected back. Now incident EM wave is going in minus x direction, and whenever it hits the x equal to 0, then it goes in plus x direction, then it won't change. So that is regarding direction. Now at the conductor surface, tangential component of total electric field is 0. So total electric field tangential component means tangential component of incident electric field plus tangential component of reflected electric field gives total tangential component at the conductor surface. So that is 0. From that you get tangential component of reflected field. Then you don't know the component of you do not know normal component value, then you give some name to that normal electric field for reflected wave. Then you know for uniform plane wave one property is there, unit vector in power flow direction dot product with unit vector in electric field direction gives 0. From that you will calculate that one. Ultimately you have to put that here. So this is the procedure, right? Now next question. This is question number 43 in regular workbook. In GATE workbook, it is question number 37. Okay, right. Here, you see which what is the polarization you have to find. Actually, I told you it is uniform plane wave. If wave travels in here, wave is traveling in, you can see minus, you multiply here. If you multiply minus, then you get plus kx. Plus kx means wave is traveling in minus x direction. So for wave traveling in minus x direction, then electric field should have perpendicular to electric field component should be perpendicular to the x. That means y and z. So in uniform plane wave, if wave travels in z direction, then electric field should not have z component. Then electric field should have x comma y components only. Similarly, if a wave travels in x direction, for wave traveling in x direction, then electric field will have y comma z components. So here for uniform plane wave traveling in, this is minus x direction, then electric field components should have E naught into y plus j2 y cap j2 z cap. Can you tell me what is the polarization of this one, dear students? Here it is written as beside y cap 1 into e power j0 plus 2 magnitude e power j pi by 2 z cap. So here it is 1 into e power j0 y cap. So here magnitude is 1 and 2, different magnitudes, and second component leads first component. Second component leads first component by 90 degrees. So this is which polarization? Elliptical polarization. If you see answers, in first option, it does not represent a plane wave, we said. Next, circular polarization, no. Represents an elliptically polarized plane wave propagating along xy plane. So here it is wave is traveling in minus x comma plus y direction. That means that is xy plane only. So it is elliptical polarization. So different magnitudes and phase difference is phase difference is equal to pi by 2 minus 0 is pi by 2. So this is not linear polarization, for that same phase should be there. This is not circular polarization, for that equal magnitude should be there. And so if it is not linear, it is not circular, so it is elliptical polarization. Similarly, if you take this one also, for uniform plane wave traveling in here plus y direction, electric field will be E naught, then you have to take X component and Z component. Okay, X component and Z component. So once again it is elliptical polarization. Elliptical polarization. Okay, so the option is C actually. Answer is C. Some students may ask, sir, how to decide whether it is a plane wave or not. I told no. For this power flow unit vector is equal to, how to write this? Here you send this minus here. If you send this minus here, then you will have e power j omega t, e power j omega t, then plus kx minus ky is there. I told you how to write unit vector and power flow direction. Whatever is there, you take opposite sign, so minus k, and in place of x you write ax cap, and here whatever is there you take opposite sign plus k, then you take ay cap divided by k square plus k square, that is nothing but root 2 k na. So then k cancel, minus ax plus ay divided by root 2 you get. Now what is the unit vector in electric field direction? Now no need to solve, you see here. Here x component is minus 1 by root 2, and you can see here ultimately what do you say, you have ae cap is equal to x cap plus y cap plus j2, what do you say, z cap. Here modulus of this is root of 1 square, and this is 2 square. Actually mod you have to take, mod of this is 2 square you have to take. So now you take the dot product, then automatically what will happen here? So AP dot AE is equal to minus AX plus AY divided by root 2 dot AX cap, X cap is AX cap plus AY cap, then J2 AZ cap divided by some term, this is root 6, root 6. So that is equal to 1 divided by root 2 root 6. Now this one ax dot ax minus 1 plus ay dot ay 1, then az is not there, 0. So that is equal to 0. So that means ap dot ae 0 means that represents uniform plane wave. So in option in A it is given, it does not represent uniform plane wave. So that is wrong option. Just I checked here whether it is uniform plane wave or not. So ap dot ae is 0, so it is uniform plane wave, right? Now next question. So students, let us see this question. An EM wave decays to 20% of its initial value. Decays to meaning is decreases and that much remains. So 20% means 0.2. 0.2 of its initial value is EI0 after traveling a distance of 5 meter in a lossy medium. In a lossy medium means alpha is there. So I will write like this, in a lossy medium, in a lossy medium, amplitude of electric field for z distance is equal to EA0 into e power minus alpha z. This is formula actually. Now for z is equal to 5 meter distance, electric field amplitude is equal to EI0 e power minus alpha into z is equal to 5. This is formula. Now in the question it is given that it decays to 20% of its initial value. That means it becomes 0.2 of its initial value. That much remains. Decays to means decreases and that much remains 0.2 EA0. Now it is given in the question. From this EA0 cancel. So e power minus alpha 5 is equal to 0.2. That means this is 1 by 5, no? Yeah, 1 by 5. So e power alpha 5 is equal to 5 you get. Now this value alpha 5 is equal to ln 5. So that means alpha is equal to 1 by 5 ln base 5. So alpha value, how much you get? This is 0.321 you get. From first information, we found alpha value for that. Next, what is the distance traveled by the wave where the amplitude decays to 40% of its initial value? Okay. Now, that means let at z dash distance amplitude is 40% means 0.4 EA0. Then EA0 e power minus alpha z dash is equal to 0.4 EA0. So we have assumed that at z dash distance magnitude decreases and this much remains. Now we have to find what is z dash. Okay, EA0 cancel. So e power minus alpha. So alpha is 0.321 0.321 z dash is equal to 0.4. From this, if you calculate z dash student, so this is z dash. From this, if you calculate z dash, na, you will get z dash is equal to 1 by 0.321 ln 2.5. So that is nothing but 2.854 meter you get. Okay. Now, next question is question number 45, regular workbook, GATE workbook question number 39. The loss tangent in a certain medium is the loss tangent in a certain medium is so loss tangent is actually tan theta 1.73 is given. Then phase difference between E and H vectors of the EM wave in medium is. Then find theta eta. You have to find theta eta. So here theta is equal to tan inverse of 1.73. That is nothing but theta is equal to you get 60 degree students. We know that relation between theta and theta eta. Already I wrote in the note. Theta is equal to 2 times theta eta. So that means this is theta eta is equal to theta by 2, that is 60 by 2. So theta eta is 30. This is the answer. This gives phase difference between E and H. Already I wrote this in the note, no? For example, in electric field, no, cos omega t minus beta z is there. Then in magnetic field, cos omega t minus beta z plus or minus 30 will be there. That is the meaning of that. Okay. Next question. That is question number 46, no? Okay. Question number 46 in regular workbook. Then EC workbook question number 40. Okay. The ratio of attenuation constant to phase shift constant of the material is. So given attenuation constant to phase shift constant ratio is 0.5. Calculate the loss tangent. Find loss tangent, that is sigma by omega epsilon. That is the question actually. So what we do, dear students, we know that first I will write alpha. Alpha is omega root mu epsilon by 2, then root of 1 plus sigma by omega epsilon whole square minus 1. So this is the formula under root. Then beta is omega root mu epsilon by 2 and root of 1 plus sigma by omega epsilon whole square. Beta is plus 1. Now ultimately this cancel, mu epsilon by 2 cancel. Then I will take alpha by beta whole square is equal to 1 plus sigma by omega epsilon square root minus 1 divided by root of 1 plus sigma by omega epsilon whole square plus 1. So here alpha by beta whole square is nothing but alpha beta 1 by 2, 1 by 4, that is. So that is 1 by 4, right? And shall I write here 1 by 4 alpha by beta whole square, that is 1 by 2 square. Alpha by beta is 1 by 2, 1 by 2 square. So 1 by 4, that is. Now if you cross multiply, you get 1 plus sigma by omega epsilon whole square. This is plus 1. Here you have to multiply with 4. So 4, 1 plus sigma by omega epsilon minus 4 you get. So now let us get this side. No, send this side, this side. So 3 times root of 1 plus sigma by omega epsilon whole square is equal to, sending this side. So now 1 plus whole square is equal to 5 by 3 whole square. Okay. And sigma by omega epsilon whole square is equal to 25 by 9 minus 1. And ultimately sigma by omega epsilon is equal to, this is it seems 16, no? You get 4 by 3, students. 4 by 3. So this is the loss tangent. Loss tangent. This is the answer. Now next question. That is question number, in regular workbook, question number 47, and this is 41 in GATE workbook, right? So a certain medium has given alpha is equal to 2 by 3 and loss tangent is equal to 2 root 2. Okay, find F frequency, and also given epsilon is equal to 1 and non-magnetic medium. So non-magnetic medium, for magnetic medium mu r is greater than 1, for non-magnetic medium mu r is equal to 1. So this formula is this one only, alpha is equal to omega root mu naught epsilon naught by 2, because he has given epsilon r 1 and mu r also 1. Now root of 1 plus sigma by omega whole square and minus 1. So dear students, here I will do like this, whole power 1 by 4. So here alpha is given 2 by 3 and we want this omega. We will do one thing. So 2 by 3 is equal to, now omega is 2 pi f. Okay, then I will write this Directly we will send it there. Directly we will send that side, na, it will be easier. Okay. So omega is equal to, you send this side, the denominator goes here. So alpha times root 2 divided by root mu naught epsilon naught. Then it is in the numerator, it goes to denominator. That is 1 plus this value is given, last tangent, this one, 2 root 2 square. So I will put 2 root 2 only. 2 root 2 square under root and minus 1. Again root is there. So here omega is equal to, f is equal to 2 pi f, na. Then alpha is given as 2 by 3. Alpha is 2 by 3 and then root 2. Then 1 by root mu naught epsilon naught, here f, na, 2 pi is there. Because omega, this is 2 pi bottom side. Then alpha is 2 by 3. So then root 2 is there. Then what is this? 1 by root mu naught epsilon naught is 3 into 10 to the power 8. Then this is 4 into 2, 8. Am I right? 4 into 2, 8. 8 plus 1, 9. Root 9 is 3. Yes, it is 3. 3 minus 1, 2. So root 2 you get. Okay. Now that implies f is equal to, you calculate that one, student, whatever it might be the value. So that is the f value. Okay. Calculate that one. So students, let us see this question. The electric field intensity of a plane wave traveling in free space, air medium, is given by the following equation. This is the electric field equation. In this field, consider a square area of 10 centimeter by 10 centimeter on a plane x plus y is equal to 1. That means there is one surface. Thus, on that surface equation is x plus y is equal to 1. Then on that big surface, some area is taken here. Then how much power crosses that area because of this electric field that is given. So the total time average power passing through the square area. That's what I was telling. So you have to calculate in milliwatt. So first what you do, surface function is f of x comma y comma z is equal to, this is surface function x plus y minus 1. Now grad f is equal to dou f by dou x ax plus dou f by dou y ay plus dou f by dou z az. Now partial differentiation of f with respect to x means you get 1. So 1 ax. Partial differentiation of function f with respect to y means you get 1. So 1 ay. Partial differentiation of function f with respect to z you get 0. This is grad f. So normal unit vector to the surface is grad f by modulus of grad f, that is equal to ax plus ay divided by root of 1 square plus 1 square. So this is that one. Now surface vector s bar is equal to area into normal unit vector. So here area is given as 10 into 10 and 10 to the power minus 4. So that is 10 to the power, I am writing, okay. So this is the area, okay. Then ax plus ay divided by root 2. So that means this is 10 power minus 2 divided by root 2 ax plus ay meter square is surface vector. Okay. Next, average Poynting vector in free space given electric field half a0 square for free space eta naught, then unit vector in power flow direction half into a0 is 24 pi. So 24 pi square divided by 120 pi. This wave is propagating in plus x direction. So power flow direction is plus x actually, right? Now average power crossing the given area is PAVG is equal to double integral PAVG bar dot ds bar. You can see here PAVG bar is uniform. Uniform means it is not a function of distance. So PAVG bar is uniform. So average power is PAVG bar comes out, then double integral ds bar means s bar. So this is half into 24 pi whole square. Yeah, that is fine. So 120 pi ax, then 10 to the power minus 2, this one, by root 2 ax plus ay. So dear students, here half 24 pi whole square 120 pi, then here x coefficient is 10 power minus 2 by root 2. So 10 power minus 2 by root 2. Then ax dot ax is 1. Then this term will become 0. So this is the answer. These many watts you get. Okay. In milliwatt if you want, so 24 pi, okay, by root 2 milliwatt you get. See that calculation, this is watt, so then these many milliwatts you get. Okay. Next question is question number 49 in regular workbook, GATE workbook, question number 43. Assume that a plane wave in air medium, so medium is air, with an electric field E bar is 10 cos omega t minus 3x minus root 3 z ay volt per meter is incident on a non-magnetic dielectric slab of relative permittivity. Actually I will write like this: epsilon r2 for second medium is 3, which covers the region this is important point, z greater than 0. In solving question, this is important one. The angle of transmission in the dielectric slab is the angle of transmission in the dielectric slab is, that means you have to find theta t. Okay. So here I am going to draw this diagram. You see here, students, what is important point here is actually this is important point, z greater than 0. That means you can see here first air medium is there, then medium 2 is a dielectric, this is z is equal to 0, and he is saying this dielectric is for z greater than 0, automatically this air medium is for z less than 0. So this is dielectric medium. He has given it is non-magnetic, so epsilon r2 is 3 he has given here, which covers this region. The angle of transmission is, now this is boundary surface. Can you tell me, dear students, what is this? Normal unit vector to the boundary surface. Normal unit vector to the boundary surface. For example, if this is the incident wave, it makes, let us say, theta I angle with the normal, then definitely this is the transmitted, it makes theta t angle. See, dear students, here important point is this one. He is saying this EM wave having this much electric field traveling in air medium is incident on a non-magnetic dielectric slab of epsilon r2 is equal to 3, which covers the region z greater than 0. That means for z greater than 0, this is there. So whichever wave travels here in z direction hits this boundary, and then that crosses z is greater than 0. For example, x greater than 0 is given now, then you have to talk of x component here. Okay, now you have to find theta t. So here if you know theta I, then automatically you can find theta t using the Snell's law. Okay, that is this actually, this is normal unit vector, that is equal to which axis is that? This is z axis actually, az cap. Okay, in this diagram it is az cap. For example, for z is equal to 0 boundary like this, then the normal unit vector is az, so that is an cap. So, dear students, now what is theta I? Angle between incident wave, that means EM wave, and the az cap. So, angle between incident EM wave and az cap in direction cosines, that is called as c degrees. Angle between incident wave and z axis is called c degrees in directional cosines. So, angle between incident wave and az cap is c degrees. That itself is nothing but theta I here, theta I. So now do you remember generalized wave equation? In the generalized wave equation, if you recall generalized wave equation, what is this? This is beta cos a degrees, that is beta x is 3, and then beta cos b degrees, here y is not there, then beta cos c degrees is equal to root 3 is given. Now you sum of them, beta square cos square a degrees, beta square cos square b degrees, beta square cos square c degrees is equal to 3 square plus 0 square plus root 3 square, and ultimately beta square is common here, cos square a, cos square b, cos square c is 1. So that is equal to 9 plus 3, 12. That implies beta is equal to 4 into 3, that means 2 root 3 it is. Now substitute this one here. Let us say this is 1, this is 2, this is 3, this is 4. So put equation 4 in 3, then beta value is 2 root 3 here na. Then cos c degrees is equal to root 3, root 3 gone. Cos c degrees is equal to 1 by 2, implies c degrees is equal to 60. That means what is c in direction cosines? Angle between incident wave and the z axis, that is c degrees. So here that is nothing but theta I. So theta I is equal to c degrees, that is equal to 60. Now Snell's law is n1, that is root epsilon r1 sin theta I is equal to root epsilon r2 sin theta t. So air medium, so 1, then sin 60 is equal to root of epsilon r2 is given 3, then sin theta t. So this is root 3 by 2 na. Ultimately sin theta t is equal to root 3 by 2, root 3, 1 by 2 you get na. So that means theta t is equal to 30 degrees is the answer, students, right? So question number 50, regular workbook. In GATE workbook, question number 44. Right. For GATE students also I have solved all the questions. You have to solve them because they are all conceptual questions. So here it is given, I am drawing the diagram here. What is this diagram? This is medium 2, dielectric is there, So this is medium 2. And for this mu r is 1 minus J2, epsilon r is 1 minus J2. Okay, this is air, that is medium 1. And here some electric field is coming, having the magnitude of incident electric field is 10 volt per meter and frequency is 1.1 gigahertz. Now question is, inside this dielectric having complex relative permittivity and permeability at 10 centimeter distance, what is the magnitude of electric field? So that is the question, dear students. So here dielectric he is saying that means sigma 0, students. In this sigma is 0. Okay. Now here incident wave EI0 is given as 10 actually. Here no, it is given 10 EI0. Now at this location electric field is equal to EI0 into e power minus of alpha into Z. Here Z is 10 centimeter actually. That means when wave travels 10 centimeter distance into this medium, what happens to the electric field? EI0 into e power minus alpha Z. EI0 is 10 here because air medium is lossless medium. Anywhere here 10 volt per meter, here also 10 volt per meter. Incident is 10 volt per meter. So ultimately it is 10 e power minus alpha into 10 centimeter, that is 10 power minus 2. So this much electric field value is there at this location. Now you have to find alpha. So if alpha is 0, then here 10 is there. But if alpha is not 0, you have to calculate that value. So here this one. So now I am talking of what do you say, alpha value. Here sigma 0, then gamma is equal to j omega root mu epsilon. Okay. Now that implies gamma is equal to j omega 1 by root mu naught epsilon naught. Okay. So root mu r epsilon r. For a dielectric medium, gamma is equal to j omega is 2 into pi into 1.1 into 10 to the power 9 divided by, this is actually c, so that is light velocity 3 into 10 power 8. Then root mu r is 1 minus j2, epsilon r is also 1 minus j2 under root. So this value becomes j into this one is 2 pi into 11, then divided by 3. So 10 power 8, 10 power 8 cancel, 1 minus j2. So ultimately this value becomes j2 pi 11 by 3, 1 minus j2. From this alpha plus j beta is gamma. Gamma is alpha plus j beta, student. So 4 pi into 11 divided by 3, because j into j square, minus 1 into minus 1 plus 2 into 2, 4 pi 11 by 3, and beta we are not bothered about that. Anyway you can write here j 2 pi 11 divided by 3. From this alpha is equal to 4 pi into 11 divided by 3. So that is nothing but the 46.0533. Okay. Now electric field in dielectric at z is equal to 10 centimeter is equal to EI0, this one only, 10 into e power minus of 46.0533 into 10 into 10 power minus 2, 10 centimeter. So this value becomes 0.0999 volt per meter. Right, students? We have solved all the questions. Now actually pointing theorem is there. We did not discuss that. If we want, if you want, you can we can discuss, but that is not useful for objective exams. Then that is in IES exam. That is conventional question actually. If you want, I will derive that, but maybe that statement is required for you. Anyway, it will take very less time. If you want, we will do. That is pointing theorem. Pointing theorem. Maxwell equations for linear homogeneous isotropic medium, or del cross E is equal to minus of dou B by dou T. Actually, B bar is equal to mu into H. So del cross E is equal to minus of mu into dou H bar by dou T, equation number 1. Now del cross H, second equation, J bar plus dou D bar by dou T. So del cross H is equal to, J bar is sigma E bar, D is equal to epsilon E. So dou E bar by dou T. Now pointing theorem talks of pointing vector first. Pointing vector is E bar cross H bar, but here E bar del cross E is there, del cross H is there, but there is no E bar cross H bar. So then we have to go to the mathematics and we have to search for the equation which gives relation between del cross E, del cross H and E cross H. So like this equation, na. So here in maths, na, divergence of A bar cross B bar is equal to del cross A dot B bar minus of del cross B bar dot A bar. One formula is there in mathematics. Here A bar comma B bar are vectors. Okay, this gives A bar cross B bar, del bar cross A bar, del bar cross B bar relation it gives. Now let A bar is equal to E bar and B bar is equal to H bar in equation 3. Then we get del dot E bar cross H bar. This is what pointing vector. So E bar cross H bar. So del cross E bar dot H bar minus dot E bar is equation number 4. Now del cross E is here and del cross H is here. Substitute them. So put 1 comma 2 in equation number 4. Okay. Now del dot E bar cross H bar is equal to, del cross E is minus mu into dou H bar by dou T dot H bar, then minus of del cross H is sigma E bar plus epsilon dou E bar by dou T, then E bar is there. Okay, here E bar. So E bar cross H bar is equal to, first I will write this one, later on also we can write that. Okay, here minus epsilon dou E bar by dou T dot E bar, then minus mu dou H bar by dou T dot H bar minus sigma E bar dot E bar here, sigma E bar dot E bar. So for this also dot E bar minus sign I wrote here. Let us say this is equation number 5, dear students. Here now we know that in dot products A bar dot B bar is equal to B bar dot A bar. This E bar can be written here also. In dot products you can interchange them. Now I am doing this one. You see, d by dt of half into epsilon into mod E square. Let us see what happens to this one. It is mathematics actually. You do this one. This is nothing but half into epsilon constant. D by dt of E square is 2 into dE bar by dt. 1 minute. So d by dt of E square is 2 into mod E into d mod E by dt. It is correct, na? Yes. Now this 2 cancel. I will write epsilon, and this is nothing but E bar dot dou E bar by dou t. That is nothing but epsilon dou E bar by dou t dot E bar. This is actually little mathematics. Okay. Anyway, this no need to write here because this one. So dear students, you may confuse that, sir, how did you write this one from this one? It is like A bar dot A bar electric field is there. Electric field has here you come. Electric field is there. For example, it has x component, let us say. Then if you differentiate that with time, then that also will have x component. So Ax dot Ax is 1. So this magnitude remains. That is the explanation for that. Simple student, electric field direction and time differentiation of electric field direction both are same. So their dot product becomes 1. So that is why this one and this one both are same. Now this term epsilon E bar dot dou E bar by dou t can be written like this. Similarly, that term also. Again, I am telling, don't confuse. This E bar dot dou E bar by dou t, or otherwise dou E bar by dou t dot E bar, both are same because A bar dot B bar is equal to B bar dot A bar. So now you can write this equation like this: cross H bar is equal to, this can be written like this. Minus is there for both of them common. Then dou by dou t half epsilon mod E square for this and for this half mu mod H square minus of this one is actually sigma into mod E square. So equation number 6. Why we have written this, you might have understood now. Half epsilon mod E square is energy density. D by dt of energy density is power density, watt per meter cube. And here also it is heat power density. Because sigma is there, sigma is there means resistance, student. Sigma is there means resistance. Resistance means heat loss it gives. So if you want, you can see the units. This is 1 by ohm meter. The unit of this is volt square by meter square. Volt square by ohm. V square by R is watt. Watt per meter cube. That is power density actually. So that is heat loss power density. Okay. Now let us take volume integral both sides. Okay. Take volume integral both sides. You know why I am taking volume integral? I was telling you that watt per meter cube you are getting. If you take volume integral means then you get power relations. So triple integral E bar cross H bar dV is equal to okay, we will take anyway minus of triple integral dou by dou t plus half mu mod H square dV. Dear students, minus na I brought outside. So this term is as it is written, triple integral dV is taken, and again minus triple integral dV is taken. So let us say this equation number what do you say, 7. Okay, from divergence theorem, double closed E bar cross H bar dot ds bar is equal to triple integral divergence of this vector, that is pointing vector, of dV. So here in place of this one you can substitute this one. So put equation 8 in 7. I will write there. Here place is not sufficient. So now that becomes like this, E bar cross H bar dot ds bar is equal to minus of dear students, you can see here this integration is with respect to distance xyz, but d by dt is with respect to time. Time and distance are independent, so d by dt can come outside now. So minus of d by dt and then triple integral half epsilon mod e square plus half mu mod h square dV, okay, minus of triple integral sigma mod e square dV. Let us say this is equation number 9. 8 over 9 this is, okay. Now what is going on here? क्या चल रहा है इधर? I will explain, you see now. Here this is air medium. Here one antenna is there. From this antenna EM wave is going like this. That EM wave has electric field and magnetic field. Now for example, then in the path of the EM wave I have imagined one volume. जो EM wave ऐसा जा रहा है उसका रास्ता में एक वॉल्यूम इमेजिन किया मैंने, ऐसा एक वॉल्यूम इमेजिन किया. सो थोड़ा सा बड़ा कर देता हूँ, आपको आसान से दिख जाएगा. I have considered one volume here. Let us say this volume is delta V or dV. Now here some antenna is there, transmitting antenna, TX antenna is there. From this EM wave is going like this it is EM wave is going. Now this EM wave has some energy, that means it has some power. Let us say it has 10 watts power. 10 watt power. That power enters into this and here in epsilon that means capacitor, and mu that means inductor. Epsilon and mu they store the energy here, na? Epsilon and mu they store the energy, that means they store the power. So how much power they have stored, both of them? 10 watt they have stored. So dear students, it is like this. Here EM wave is coming that has some power. Now we are standing here, actually EM wave is going here and that has 10 watt power. Now I am standing here and observing in this volume what happens. Then in that volume epsilon mu store that power 10 watt. Then the stored power is this one. That means this is energy density, this one is energy density multiplied with volume gives energy. This is energy density multiplied with volume gives energy. D by dt of energy is power. that much power is there here, that is 10 watts power is there. That much power is there in epsilon and mu. Now, whatever power is there here, after some time this will come out. So, this is actually a closed surface, or otherwise inside this closed surface volume is there. Now, how much power come out of this? Double integral E cross H dot ds bar. This means this is volt per meter by ampere per meter, volt into ampere per meter square. That means watt per meter square into meter square is watt. How much power is going out of this volume? How much power is going out of this volume? So, power going out of the closed surface, or otherwise power going out of the volume, both are same, is equal to, if some power is going here means out of this volume means in this volume that much power should decrease. So how much power is there? 10 watts. Out of 10 watts in this volume, because of sigma, then let us say 2 watt is dissipated. 2 watt is dissipated in the form of heat. Are you able to understand? This EM wave is supplying 10 watts to this volume, and in that volume sigma is there. Because of the 2 watt heat loss is there. Now that is not useful, that is released into the heat. Now how much remaining? 8 watts. That 8 watts only goes out. So 8 watt is going out. Now I am concluding statement. Power going out of this volume is equal to how much decreased here? 10 watts. Because if 10 watts decrease here, then only that goes outside. So 10 watts power decreased in epsilon and mu. From that power 2 watts is dissipated here and 8 watt is going out, because power can be created nor destroyed. So it is like this now. 8 watts is coming because 10 watts power is decreased in this volume. Out of 10 watts, 2 watts is dissipated in the form of heat, and 8 watt is coming out. So that is this one. That is why this 2 watt is called as ohmic power losses. Ohmic power losses, that is. This you need not to explain anywhere in the derivation. Simply you have to write that one. So now you can see, students, this is energy density. Into volume gives energy. d by dt of energy is power. Minus means that much power decreases in this volume. And how much power is decreasing in this volume? 10 watts you have to say. Don't say minus 10 watt. You have to say 10 watts. So this is all including this one, including minus. Answer is 10 watts. Minus this is 2 watts. So 10 watt minus 2 watt is equal to 8 watt is going out. This is going out actually. So now how you write this one? How you write this one? d by dt means rate of. D by dt means rate of. Minus means decrease. Rate of. Minus means decrease of. This is electric energy density. This is magnetic energy density multiplied with volume. Then you get electric energy and magnetic energy. So rate of decrease of electric and magnetic energy within the del V or otherwise dV within the volume, you say, student, because inside this closed surface whatever volume is there, that much. So within the volume, the meaning of this one is this one, minus of, the meaning of this one is ohmic power loss. That is the statement. Now, so I am writing the statement here. Pointing theorem statement. This one only we have to write. Pointing theorem states that the total average, always we talk of average power, total average power going out of the closed surface, going out of the closed surface is equal to the rate of decrease of electric and magnetic energy within the volume. Of course, that volume is inside that closed surface. Within the volume minus ohmic power loss within the volume. Of course, this volume is inside that closed surface. This is the statement of the Pointing theorem. This is the equation of that Pointing theorem, dear students. Okay.